Gentlemen, we were talking about great partnerships already today, and as our main topic today is sustainability, the cloud, is it still working? Yes, it is. We want to present to you another great team, and you heard the name of the company joining us here on stage already today. It's Cloud and Heat. Welcome Innovation Manager Maria Vaquero. And she's accompanied by, and I think she's going to open actually this presentation, Sonja Pierer. You might remember her from yesterday from our opening keynote already, from Intel Business Consumption Director. Ladies and gentlemen, please welcome here on stage Sonja and Maria.
Hi again. I hope you already had a good time the last 1.5 days. And today I would like to add the topic what we discussed already yesterday. And this is about the path to sustainable cloud services. We have seen already yesterday this slide where we went into how we can reduce the operational carbon footprint. And today, we discuss this more in detail. We are looking into how we can reduce that into the data center, and this is the topic we will concentrate us today. We did talk yesterday about it, that the average data center PUE is around 1.58. We are discussing now how we get through best practices Intel is doing as well with other ecosystem and partners, how we can reduce them to less than 1.1. And this is really interesting because we are describing how we can use liquid immersion into this, how we can include other topics into that. And we do this together with our partner, Cloud and Heat. And with that, I would like to introduce Maria. She's an innovation manager at Cloud and Heat, and she will present more in detail how this is going. So, good luck.
Thank you very much, Sonja. Thank you. So, good morning to everyone. It is a pleasure for me to be here today to talk about how we can make cloud infrastructures more sustainable and also the cloud services that we provide with those infrastructures. We are very grateful to Intel for the opportunity to share this keynote today. And the first thing that I would like to do is to briefly discuss why a sustainable cloud is so important. I think most of you don't need convincing, but anyway, it's sometimes good to go through a few facts that we have. And we know that digital technologies have a huge potential to improve some of the challenges that we have nowadays in different industries and different fields. But we also know that these digital technologies are often very resource-consuming, so they require a lot of energy to be developed and deployed. Artificial intelligence is a paradigmatic example of this. So I think most of us are very optimistic. We've seen what artificial intelligence can do, and we think that it can do more things in the future, in the industry, mobility, even to protect the environment, medicine. But it's very resource-consuming to train these models and to deploy them. So just an example of a fact that's interesting, an algorithm that was developed so that a robot hand could solve a Rubik's Cube problem. To develop this algorithm, the environmental impact was equivalent in terms of the CO2 footprint to 3,000 flights from Berlin to Chicago. So huge potential, but also very resource-consuming. And the past years have shown how the consumption of data centers has risen, whether it be cloud, edge, or on-premise data centers, and the forecasts say that this will continue to be so in the future, right? So we expect in Europe that by 2030, 3% of the total energy consumption of the data centers, so 3% of the total energy consumption will be associated to data centers. So this is why if we want to benefit from the solution of digital technologies provide, we also need to find ways to do this sustainably. I want to talk today about a few approaches that we have to this. So there's multiple ways to approach this. I think many of them have already been presented at this conference. And Cloud and Heat is a relatively small cloud provider and provider of cloud solutions. And I want to talk today about what we are experts in, right? We are experts in achieving energy efficiency through efficient cooling technologies. We're also experts in recovering waste heat of data centers, and we always use renewable energies. So this is what I want to talk today as a possible path to achieve sustainable cloud infrastructures and then sustainable cloud services based on those infrastructures. I think most of you are familiar with the PUE value, which Sonja has already mentioned. It's just a measure that we use to compute how much of the energy consumption of the data center is related to IT, right? So we divide the total energy consumption of a data center by the consumption to the IT. By the IT. The IT is what provides value to a data center, so everything that's on top of that consumption is something that we want to reduce. The highest efficiency would be reached with a PUE value of 1.0. This is a theoretical value, but anything on top of 1.0 is just something that you need to do to operate the data center, but which is not delivering value. And as Sonja has already mentioned, we have PUE values nowadays that are around 1.5 on average. So this means that for every watt of energy that's consumed by IT, and another half watt is being consumed by other components of the data center. And most of this is related to cooling. So if we reduce the amount of energy that we need for cooling, then we are increasing the efficiency of our infrastructure significantly. What we do in Cloud and Heat is we use a direct hot liquid cooling technology, which we've developed. And what this technology does is instead of using air to cool the air components, it uses a liquid, which is mostly water, which flows through the different components of a server, the CPUs, RAMs, and so on, and cools them down. And we work with high temperatures, so the water, the liquid comes in at temperatures of around 55 degrees maximum, and leaves the server at temperatures that can be as high as 60 degrees. So the advantages of this are several. First, water has a much higher specific heat capacity than air, so it's much more efficient at removing heat than air. Second, because we work with high temperatures, it is much easier to release this heat into the surroundings. So with air cooling, you usually need some form of compression cooling to cool down the air, but we can do this with a normal heat exchanger. So we've partnered with Intel in this area. We are working on modular data centers, modular digital infrastructures that we can use, that we can deploy with high energy efficiency. So we are using liquid-cooled hardware from Intel, liquid-cooled servers, like from their Walker parts of the 90 generation. And we've combined them with our technology, which allows us to have very efficient operations even in regions of the world where temperatures are very high, because of what I was talking about, that we work with high temperatures and it's easy to cool it to the surroundings, even when the temperatures outside are very high. Another advantage of working with high temperatures and working with direct hot liquid cooling is that it's very useful to reuse the heat. So in a normal standard data center with no energy reuse, 100% of the energy that's consumed by the data center is transformed into heat and then released into the air in the form of waste. What we can do is we can try to find ways to reuse this heat and turn this into an asset, which of course has a lot of implications also for sustainability, because if you reuse the waste heat for a specific purpose, then you don't have to produce additional energy that you would otherwise have to do for that purpose. So there are multiple ways in which we can use waste heat. The ones that we are more familiar with and that we work with at Cloud and Heat are to reuse the waste heat in the same building where the data center or the infrastructure is, for heating or for delivering hot water to that building. You can also couple data center to a district heating network and distribute this heat to surrounding residential areas, for example. And there are many other things that you can do with waste heat. So basically, it's worth exploring any use case where heat is required. For example, in agriculture, you can use waste heat to heat greenhouses. You can also use waste heat to heat fields. It's possible also to explore areas like desalination. Can we use waste heat to desalinate water? And many other options. Heating swimming pools, basically the options are unlimited. We have some calculations, for example, data centers in Frankfurt, and with a 550 kilowatt data center coupled to a district heating, we calculate that it would be possible to reuse more than 40% of the waste heat of that data center. And this is very significant because the forecasts say that in a few years, the amount of heat produced by data centers in Frankfurt would be enough to heat all the offices and all the households in the city. So we have a huge potential here and to turn waste heat into an asset and improve the sustainability of these infrastructures. The last thing that I want to talk about is the use of renewable energies to power data centers. So a data center can be powered with the normal electricity that's based on the energy mix of a specific region or a specific country. This varies from region to region, from country to country. It also varies depending on the time of the day. But in Europe, we have an average of 40%, a bit lower than 40% renewable energies in our energy mix. So of course, if one switches to renewable energies, this also has a significant impact on the sustainability. You can enter into a contract with an energy provider that delivers electricity that's being produced somewhere. This is backed up by certificates based on renewable energies. But now there's a third option, which is to couple the digital infrastructures or the data centers really with the energy production. So placing a data center there where the energy is being produced based on renewable sources. And then this has also the advantage that first, you're very certain of the origin of that energy. And second, it's also a strategy to promote that more renewable energy sites are built. So this is another option to improve the sustainability of infrastructures. The solutions can be combined. So I have here an example of a project that we have with partner Vattenfall, where modular data centers are coupled to energy production, renewable energy production. In this case, it's a biomass power plant, and they're also coupled to the district heating network, meaning that the waste energy can be used to provide heating to local municipalities or residential areas in the area. And we expect here to be able to use around 80% of the waste heat that's being produced by the data centers. Again, because we have the energy efficient direct hot liquid cooling, we can achieve very low PUE values. So we have designed PUE values of around 1.07, so even below 1.1. And combining these solutions has a very, very high potential to improve our infrastructures and also the services that we deliver with them. Here, there is also an example of some calculations that we have to measure what can actually be saved by combining these technologies. So this is based on a data center in Frankfurt, which we operate, and we've calculated that the combination of energy efficient cooling and waste heat recovery, which in this case is used for heating and hot water in the building, can save up to 710 tons of CO2 per year. So just so that you have an idea, because sometimes this is hard to picture, but it's equivalent to 90 football fields of forest or to planting over 50,000 trees. So this shows the real potential of these technologies. And what's more, it's not only positive in terms of the environmental impact, but also in economic terms. So we've also calculated that 255,000 euros can be saved per year because of the energy that you're saving when operating a data center compared to the traditional cooled data centers. So there's a white paper that we have. You can find this on our website if you want to check these calculations and read more on this topic. It's very interesting. It's interesting for anyone who operates a data center. And what we've done also is we've used this data to create a CO2 footprint calculator. And the CO2 footprint calculator enables users of cloud services to calculate the digital impact or their environmental impact of their digital applications and compare different technologies, different data centers, and see what's possible there. This can also be found on our website, Think Green website. So if you're interested in that, that's also something interesting to check. And now, briefly, I want to show also what the future can look like. So up to now, I've been talking about data centers that are have different characteristics, might have different characteristics, and but we've been talking about a single digital infrastructure of a single data center. But in the future, if we have geographically distributed data centers that have different characteristics, for example, they're coupled to different types of energy production, renewable energy production, so one might be coupled to wind energy production, one might be coupled to solar energy production, and so on. And they are also distributed in maybe different regions that have maybe even different time zones. And maybe they're also coupled to different cases of wasted reuse. And so if we manage to operate these distributed infrastructures as a whole, then the potential is even larger. So what we would try to do is to have a system that decides where a specific workload is going to be computed and migrates these workloads automatically to maximize energy efficiency. It can also take into account other parameters, so there might be other restrictions in terms of the hardware, in terms of the latency, for example, of the applications and so on. But we can also try to optimize energy efficiency. So a specific workload might be migrated from one side to the other, depending on where the energy efficiency is higher. And this, as I said, this is where we think that the future lies and where we see a high potential to improve the sustainability of infrastructures and cloud services even more. We are working on an open source project called Kraken, which would be specifically in charge of this software-defined energetic optimization. So with this, we're coming to the end. There are a few things that I would like to share as summary. First, that it is very important that any data center that's being built now or that's being refurbished should pay attention to energy efficiency. And there are different ways to do this, but it's key that we continue to improve the energy efficiency of our data centers because it's the only way that we can reduce the environmental impact that this the industry and the applications that are on these data centers can be improved. Second, it is also important that cloud service users, so those that develop applications, for example, that they are aware of the impact of using different types of services that are hosted on different infrastructures, because they can also help them reduce their environmental impact of their applications. And then finally, what's also very important is that this is a huge challenge, so it is something that we have to face jointly, because important challenges are only solved with cooperation amongst different actors, amongst different partners, and we think this is really necessary for the future, so to build solid partnerships that help us all move forward towards this objective of sustainable cloud services and cloud infrastructures.
So thank you, Maria. It's really interesting. And with this, then I think the example of saving 700 tons in an average data center on carbon is really impressive. It's really impressive. And if we see that we have so many data centers outside, what can we achieve as a society if we are going this direction? And at Intel, you see how we are living partnerships with Cloud and Heat and obviously also others. We are really living this because this is important for us, for the ecosystem, for our partners, to provide the best solutions to you as a customer. So thank you for the insights, Maria.
Thank you very much for the invitation.
Come to us at the booth at Intel. You will also see there are a few other topics like we have discussed yesterday tomorrow we will have another keynote together with IBM, and we are looking into how we are doing SGX in electronic patients. So please also join us for this keynote tomorrow. Have a great time, have a great afternoon, have a great evening, and let's see each other tomorrow again. Thank you.
Thank you very much.
Thank you so much, ladies.